Hello, my name is Daniel Crenshaw, and this is my Lab 3 report. For this lab, we were tasked with creating a circuit with resistors in series and parallel in order to predict its behavior. The main fundamental principles used for this lab were energy conservation, specifically using the loop rule, and current conservation. While conducting the experiment, we discovered that the greater the resistance in the circuit, the lower the current output was. Here's a picture demonstrating the circuit that we made, along with a video showing the dimming of the light bulb as the energy transfers to the capacitor. For this experiment, the system consisted of the two batteries, the leads, the ammeters, the resistors, and the light bulbs, while the surroundings encompassed everything else. The materials used were two batteries, two light bulbs, two ammeters, two resistors, and leads to connect the batteries to the resistors. To conduct this experiment, we first connected the terminals of the batteries to separate resistors. One resistor was 47 ohms and the other was 100 ohms. We then used ammeters to examine the current after each resistor. Both ammeters read 20.6 milliamps. We then reversed one of the ammeter connections and the ammeter read negative 20.2 milliamps. We then made one of the ammeters a voltmeter and examined the readings again. The voltmeter read negative 1.4 volts and the ammeter read 0 amps. We then measured the potential difference across each component of the circuit. The wire was 0 volts, the batteries 3 volts, the ammeters were negative 0.4 millivolts, the 100 ohm resistor was 1.9 volts, and the 47 ohm resistor was 0.9 volts. Based on these values, the sum should be 0 because this would be a round trip for potential difference. However, our recorded number adds to 1.6, which indicates that some of our measurements were slightly off. We then connected our voltmeter across the 100 ohm resistor again and recorded 19 milliamps. When we changed the voltmeter to an ammeter, we placed it in parallel with the resistor and we recorded 20.7 milliamps. Finally, we calculated the resistance for the wires, each resistor in the ammeters. The wire had a resistance of 0, the 47 ohm resistor had a resistance of 40.3, the 100 ohm resistor had a resistance of 82.2, and the ammeters had a resistance of 2.3. For the second part of the lab, we created an RC circuit using 2 batteries, a capacitor, and 2 light bulbs. First, we took the 100 ohm light bulb and connected it to the battery and capacitor. The bulb lit and stayed illuminated for 14 seconds. Then we disconnected the bulb from the battery and connected it to just the capacitor, and the bulb again stayed lit for 14 seconds. We then repeated the process for the 20 ohm bulb. When we connected it to the battery, it dimmed in 14 seconds, and when we connected it to the capacitor, it dimmed in 58 seconds. Some possible errors that occurred during this lab were incorrect usage of the ammeters and confusing the two light bulbs and their respective ohms. It's also possible that we used the ammeters incorrectly when measuring for voltage and amps. Now, what if we charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge, and would this prediction happen in real life? If there were no resistors in the circuit, our capacitor would charge instantly. This is because there is no resistor to limit the current flow into the capacitor. However, this does not apply to a real-life scenario. This is because resistors are often used to protect hardware so that the current doesn't overload it. That is the end of the lab report. Thank you for watching.